Okay, this is section 1.4 trigonometric identities, chapter 1 from year 2 core pure maths. Okay, so one way of applying the Moivre's theorem is to find trigonometric identities. Replacement for cos 6 theta in terms of the powers of cos. That's one way of doing it. So in order to do this, the first thing we need to do is start off by defining our complex number base, if you like, basic complex number. Z is equal to cos theta plus I sine theta. Okay, so it's just modulus 1 argument theta, and we are going to use rewrite this using the Moivre's theorem. So first of all, the first step is to raise it to the power of 6. So z to the power of 6 is simply cos theta plus I sine theta to the power of 6. Okay, and there is two ways of evaluating this expression. So one way is clearly using our de Moivre's theorem. Okay, so using de Moivre's. Okay, we are going to rewrite it as cos 6 theta plus I sine 6 theta. Okay, so that's one way. The second way is using binomial expansion. Okay, so a quick binomial expansion, we are raising something to the power of 6. So if I just remind you, I'll just use Pascal triangle. You can use using the combination method, so and choose R if you like, but this is sufficient. It's quite unusual to be asked to raise an expression, complex number to the power of 6, but they do it in the textbook. I think in the exam normally it's to highest is the power of 5. Okay, so we're going to end up with 1, 2, 3, 4, 5, 6, 7 terms. There's always one extra term to what the power is. Power of 6 generates 6 terms. So we're just going to write this down. If you want to replace your cos theta with C and sine theta with S, you may want to do it because it will be quite a big expression. However, I'm going to stick to cos theta and sine theta written in full. So binomial expansion, it starts with the first term raised to the power of 6. And then you're going to have 6, the first term to the power of 5, multiplied by the second term raised to the power of 1. Next term is 15. Okay, so this would be your n choose 2. So you're going to have cos to the power of 4 theta, and then you have I sine theta to the power of 2. The powers need to add up to 6. Plus the next one, I can probably squeeze this one, 20. So this is going to be your n, or 6 choose 3. So it's going to be cos to the power of 3 theta, and then I sine theta to the power of 3. I will have to go spill on to the next line. So the next one is 15. Okay, so this time we are going to reduce cos to the power of 2, and I sine theta will get the power of 4. Carrying on like this, you get 6 cos theta, then you've got I sine theta to the power of 5, and lastly you will have I sine theta to the power of 6. Okay, the next step is to tidy this up. Okay, so let's just write it down by tidying these expressions. So it's cos to the power 6 theta plus 6 cos to the power 5 theta sine theta. I'll put I at the end here. Next one is 15. This one is going to be cos to the power 4 theta. Then it's going to be sine squared theta. And you are going to get that multiplied by I squared. Plus, I want to have enough room to squeeze the next one, so I'll put this one in the next line. 20 cos 3 theta plus times sine cube theta, and this is multiplied by I cubed. Next one is 15 cos squared theta, and then you've got sine to the power 4 theta I to the power 4 plus 6 cos theta sine to the power 5 theta I to the power 5, and last one is sine to the power 6 theta I to the power 6. When you do it next time, you will be able to do it a little bit quicker. Okay, so here we need to realize that this expression here will be a complex number. We will have real part and imaginary part. So from last year, anything multiplied by I is an imaginary part. Anything that's free of I is a real part. So if you look at this, this is contributes towards a real part. Okay, over here, this expression will also be real, because if you remember I squared, that is equal to -1. So this is going to be minus 15 times cos to the power 4 sine squared theta. Okay, this one, I'll put it on here, I cubed, so I squared is -1. I cubed is made out of I squared times I, so it's -1 times I, so that's minus I. Then if you follow through, I to the power 4 is your I squared multiplied by another I squared, so that's -1 times -1, that just takes it back to 1. I to the power 5, it's simply 1 times I to the power 4, if you like, times I, so it's 1 times I, so it's I. And I to the power 6, it's simply I to the power 5 multiplied by I, so it's -1. So if you look at this, this also is going to be real. This one is going to be replaced with 1, and this one is going to be replaced with -1. The others, this one stays as I, this is going to be minus I, this one is going to be I. So I'm going to collect the real parts together. So the ones underlined in red, so it's cos to the power 6 theta minus 15, and you've got cos to the power 4 theta sine squared theta, and then the next real part is positive 15 cos squared theta sine to the power 4 theta, and lastly you've got minus sine to the power 6 theta. This all together is the real part of that expression. Okay, this is what we've underlined in red before. Okay, and then imaginary part, so I'll put everything in brackets. It's going to be 6 cos 5 theta sine theta, and then you've got 20 cos cube theta sine cube theta, and then it was minus, apologies, forgot about that, it was I cubed, so that was minus, And this one here is positive I, so that will take you to plus 6 cos theta sine to the power 5 theta. There you go. Now, the question asks us to prove that cos 6 theta is equal to this. Now, when we expanded in using Desmos, we got this answer. When we expanded it using binomial, we got this answer. So if you look at this, this is the real part of the expansion using Desmos. This is the real part using expansion, binomial expansion. They have to be equal. The same way, if you compare the imaginary part, they will need to be equal. So since the question is not asking us to find what sine 6 theta is equal to, we just need to concentrate on the real parts. Okay, so cos 6 theta, I'll get a new piece of paper. So cos 6 theta, continuing this, just to finish it off, they are quite time consuming, obviously. The quicker you get, the more times you do it, the quicker you will get. Okay, so cos 6 theta so far is equal to cos to the power 6 theta minus 15 cos to the power 4 theta sine squared theta, and then plus 15 cos squared theta sine to the power 4 theta minus sine to the power of 6 theta. Now that is already correct, and this is already an identity that we could have been asked to derive. But if you look at the question, we want it all in terms of causes only. So 32 cos to the power of 6 to minus 48 cos to the power of 4 plus 18 cos squared minus 1. So we need to get rid of those signs. Okay, so find the replacement for sine squared, sine to the power of 4 theta, and sine to the power of 6 theta in terms of cos. So starting with sine squared. So sine squared theta, I'll do the work first and then substitute those. This is simply 1 minus cos squared theta. You can just state it. So I've got the replacement for this one. Now sine to the power of 4 theta is simply your sine squared theta that's squared. Okay, so it's 1 minus cos squared theta squared. So expanding, you get 1 minus 2 cos to the power of 4 theta plus, sorry, to the power of 2 theta plus cos to the power of 4 theta. Okay, and then sine to the power of 6 theta, you can write it as 1 minus cos squared theta cubed. What you must not do is to, the common mistake is for people to write it as, just trying to think, 1 minus sine cos to the power of 4 theta, or 1 minus cos to the power of 6 theta. That's clearly incorrect. Okay, so here I'm going to use a quick binomial expansion. There you go, so it's 1, 3, 3, 1, so it's 1 minus 3, 1 squared times cos squared. How you expand it, it's up to you. You can just choose 3 brackets. The next one is going to be plus 3, that's cos squared twice, so that will take you to cos to the power of 4 theta. And then finally, you're going to get minus cos squared theta cubed, so cos to the power of 6 theta. Okay, let me just show you exactly what I've done here. So I've used a cubed plus 3a squared b plus 3ab squared plus b cubed. You should be able to use that method quickly, or use 3 brackets by expanding 2 brackets first and then multiplying it by the 3rd bracket. Okay, so I'm now going to substitute those replacements into this equation that I've written above. So There you go. We're going to keep that as it is. This is going to be cos to the power 6 theta. Here we've replaced sine squared with 1 minus cos squared theta. Okay, I think I might just about squeeze the third term into that line. Cos squared theta, 1 minus 2 cos squared theta, add cos to the power 4 theta. Okay, let me just separate this so you don't look at that now. We need to carry on and put that last one expansion, so we're going to put minus, and all of that can be written, one of those, 1 minus 3 cos squared theta plus 3 cos to the power 4 theta minus cos to the power 6 theta. There you go. So the last thing is just to tidy up all the terms, collect them together. So let's expand these brackets. So it's cos to the power 6 theta minus 15 cos to the power 4 theta plus 15 cos to the power 6 theta plus 15 cos squared theta minus 30 cos to the power 4 theta plus 15 cos to the power 6 theta. I'll carry on here. Minus 1 plus 3 cos squared theta minus 3 cos to the power 4 theta plus cos to the power 6 theta. There you go. Let's add the causes to the power of 6 first. So you've got 1, 15, that's 16, 15, that's 31, and 1 more, 32. Cos to the power of 6 theta. Let's look at the next one. We wanted 48. Let's see if we've got minus 48 to the power of 4. So it's 30 minus 45 minus 48. Yeah, that's correct. So it's minus 48 cos to the power of 4 theta. Next one is squared. We wanted 18 of them. So let's see how many we've got. We've got 15 over here and 3 more. That is 18 cos squared theta, and we should be left with minus 1, and we are, there you go, minus 1. So this has been proven as required. Okay, now you can see that if you wish to replace in this kind of work cos theta with c and sine theta with s, you may do that, but make sure you revert back to your sine and coses in your final answer, and also defined your replacements over here. Another thing I would say in those kind of questions, make sure that if you do make a mistake, and then you clearly spot that you have made a mistake somewhere in the question, make sure you trace the mistake back and correct it in every single line. You are not going to be forgiven for written any if you forget to write the brackets, although you mean for the brackets to be there, so invisible brackets cannot be written, well, the brackets need to be written there. Okay, so next one is example 12. So over here we are going to actually, what we're going to do before, because it's better to split it into sections, normally I ask students to have a go at the questions of that type first. So I would do exercise 1D, and you could see that's question 1, A, B and C. Also question 2 can be attempted, and question 6 and 7. Okay, before you go ahead and listen to the next example.